Hello everyone. A warm welcome to all the coordinator, distinguished resource person and my dear colleague. I am Professor Mahesh Pundkar from the Department of Mechanical Engineering at the College of Engineering and Technology, Akola. I have been teaching for the last 15 years and honestly, it has been quite a journey of learning and unlearning. First of all, I want to sincerely thank the organizing team for giving me this wonderful platform to share my experiences and thoughts with all of you during this 4-week faculty development program on pedagogical method for outcome based education system. Today we are going to talk about something that I believe is absolutely critical for us as an engineering educator, active learning strategies for outcome based engineering education. Before I dive into the topic, let me ask you something, and please be honest with yourself. How many of us enter a classroom, start teaching, and for the next 50 minutes or one full hour, we are the only ones talking? And what about the student? They are sitting there, some listening, some writing notes, and some quietly using their phone. Most of us experience this, right? We prepare our notes very seriously, we enter the class fully prepared, we conduct the lecture very beautifully, and we come out feeling satisfied that the syllabus is nicely covered. But after some time, we start observing something. Students attend lectures regularly, they copy the notes properly, they even score decent mark in the examination. But when we ask them a slightly twisted question, when we ask them to like concept in different situation, when we ask them to explain it in their own word, many of them struggle. This is the moment when we realize the real learning needs something more than just beautiful lectures. And that realization, my friend, is exactly where active learning become not just important but absolutely essential. So let's start with the basic. What exactly do we mean by active learning? Now there is a common misconception I want to clear right away. When we say active learning, people sometimes think, oh, so now we should not take any lecture at all. We should just let students do everything on their own. No, that's not what it means. Active learning doesn't mean we stop teaching. It doesn't mean we remove lectures completely. What it means is that students are not just passive receiver of information. They are actively involved in the process of learning. Let me break this down for you. In traditional teaching method, and again, I am not saying they are completely wrong. The teacher is active. We are explaining, we are demonstrating, we are writing on the board. And the student, they are mostly passive. They are listening, watching, and taking notes. But in active learning, the dynamic shift. Student become active participant and we as teacher become facilitator. We create opportunities for them to think, to question, to discuss, to solve, and to analyze. Educational researchers have proven this again and again. Real learning happens only when students are both mentally and physically engaged in the learning process. Think about it. When do students actually learn something deeply? When they solve any problem themselves, when they are discussing the concept with their peers and trying to explain it, when they are asking the question because they are genuinely curious, and when they are defending their answers or approach, when they are teaching someone else. These are the moments when the magic happens. When concepts move from our teaching notes into their understanding, into their long term memory, into their skill set. So, active learning is really about shifting from sage on the stage to guide on the side. Now, let's connect this specially for engineering education because that's our context. Tell me, what is engineering fundamentally? Is it a theory based profession where you just need to memorize formulas and various definition? Not exactly. Engineering is a practice oriented problem solving design thinking discipline. An engineer in the real world has to analyze a number of complex problems, design innovative solutions, work collaboratively in teams, make critical decisions under pressure, and think creatively when standard solution doesn't work. Now, here is my question to all of you. Can we develop these abilities by just making students sit and listen to us for hours and hours? The honest answer is no. Look, I will give a very small example. When our students graduate and go to the industry, nobody is going to give them a multiple choice questions. paper. Nobody going to say, here, choose option A, B, C, or D. Instead, they will face real messy problem. Likewise, a machine suddenly breaks down on their production floor, a design fails during testing, and they need to find out why. There is a production delay, and they need to troubleshoot immediately. Quality issues crop up, and they need to investigate root cause. This situation demand thinking, analyzing, collaborating, making decision, all skill that we need to develop in the classroom itself. And this is precisely why outcome based education and active learning are not separate things, they go hand in hand. You cannot achieve one without other. Now let's talk about the outcome based education, which all of us are quite familiar with by now. Outcome based education is built on very simple philosophy. Instead of asking what did we teach, we ask what can student actually do after completing this course. It's a shift from input to output, from teaching to learning, from knowledge to competency. Active learning directly supports this philosophy because it helps students develop course outcome, program outcome, higher order thinking ability. Likewise, not just remembering, but applying, analyzing, and creating. In fact, let me be very direct here. If we want to genuinely achieve course outcome and program outcome, not just on paper for the accreditation purpose, but in reality, we simply cannot depend only on the traditional lectures. Active learning acts as the crucial bridge. It connects curriculum, classroom activities, student competencies, industry requirement. Without active learning, this bridge is incomplete. We might have excellent curriculum documents, but if students are not actively engaged in developing those competencies in the classroom, the outcomes remain theoretical only. Most of you are already familiar with the Bloom's taxonomy, but let me revisit it quickly because it's so relevant here. Bloom identified six levels of cognitive skill arranged from lower to higher order. Lower levels are remember and understand. Higher levels are apply, analyze, evaluate, and create. Now here is the reality check. In most of traditional engineering classroom, where do we spend most of our time? Honestly, at the remember and understand level. Re- Generally, remember this formula, understand this concept, this is the definition, write it down. But what does industry need? What do our program outcome demand? They need engineers who can apply, who can analyze, who can evaluate, and who can create. And here is the beautiful thing about the active learning. It naturally pushes student toward those higher level of the Bloom taxonomy. When you can ask student to solve a case study, they are applying and analyzing. When you ask them to critique a design, they are evaluating. When you ask them to propose an innovative solution, they are creating. You see, active learning is not just a teaching technique, it's a pathway to developing a higher order thinking skill that engineering demands. Now that we understand what active learning is and why it is important, let me share with you some proven practical strategies that you can start using right away. These are not theoretical concepts. These are the method that educators worldwide have tested and found effective. The first strategy is think, pair, share. This is probably the simplest and most versatile active learning strategy. You post a question or problem, give student 1 or 2 minutes to think individually. Student pair up with their neighbor and discuss their thought for 2 to 3 minutes. Some pair share their conclusion with the whole class. Second is problem based learning. This is especially powerful for engineering education. In PBL, you start with the real world problem, not with the theory. Students work in group to solve it, and in the process, they learn the concept. You can take the example. A bridge collapsed during the construction. Here is the data. Your team need to investigate why and purpose of design modification. Student will need to learn about the load calculation, material properties, safety factor, but now with the purpose and the context. Next strategy is flipped classroom. I know some of you might have heard about this, and maybe you think it's too complicated, but actually it's a quite simple. Student watch a video lecture or read material before the class, basically at the home. Class time is used for discussion, problem solving, and clarification. So instead of lecturing for 50 minutes, you use that valuable face to face time for the interaction. Next strategy is peer instruction, peer teaching. There is a famous saying, the best way to learn something is to teach it. In peer instruction, one student explain a concept to another student, or student present their solution to the class, or groups teach each other a different topic. Basically, why it works, when students have to explain something, they process it more deeply, they identify the gap in their own understanding. Example, if we consider, after teaching a topic, say, now turn to your neighbor and explain their concept in your own word. Teach them as if they missed today's class. Next strategy is case study method. This is a borrowed from the medical and business education, but it's perfect for the engineering. Present real cases of the product failure, design challenges, and manufacturing problems. Even you can take the example of Bhopal gas tragedy in 1984 from a chemical engineering safety perspective. Basically, that can develop analytical thinking, decision making, and application skill. Next strategy is just in time teaching. This is very clever strategy where you can collect the information about what students know before you teach. Day before class, send a Google form with 2 3 questions about the next topic. Student will submit the responses. You can review the responses and adjust your teaching accordingly. In classes, you focus on what students struggle with. This make basically your teaching very targeted and efficient. Minute paper or 1 minute reflection. This is perfect for the large classes because it's quick and manageable. At the end of class or even at the middle, give student 1 minute to write. What was the most important thing you learned today? What question remained unanswered? It forces student to reflect and you get the instant feedback about what worked and what didn't. Next strategy is jigsaw method. This is great for covering multiple topics efficiently. How it works? Basically divide the classes into groups. Each group becomes expert on one subtopic. Groups reform, so each new group has one expert from each topic. Expert teach their topic to their new group. Basically, students learn by teaching and you cover more ground. The next strategy is collaborative problem solving. Instead of solving a problem on the board while students watch, give them the problem. Display the problem. Student work in a small group, walk around, observe and guide them. Groups present different approaches. Discuss which approach is better and why. Basically, the key point of this strategy is there is often more than one way to solve an engineering problem. This method shows students multiple approaches. The next strategy is muddiest point. This is the simple feedback technique. At the end of topic or the class, ask what was the muddiest point for you? What is still unclear? Student will write it down anonymously. You can collect and address those points in the next class. Basically, students are often hesitate to say I don't understand. This give them a safe way to express confusion. Let's discuss quick implementation tips for this strategy. Start with only one strategy. Don't try to implement everything at once. Master one method first. Explain to student why you are doing this. Tell them we are doing this actively because it will help you learn better. Set clear time limit. If you say 5 minutes, stick to 5 minutes. Otherwise activities drag on. Have a backup plan. Sometimes what happen, an activity doesn't work as planned. Be flexible. Gradually increase the complexity. Start with the simple think pair share, then move to case studies and PBL. Remember, these strategies are tools in your teaching toolkit. Some will work better for certain topic, some for certain cases. The key is to intentional about when and why you use each strategy. Now I know what some of you might be thinking. This sounds very good in theory, but how do we actually do this in our engineering subject? So let me give you some very concrete practical example from different engineering domains. First one is strength of material. Let's say you are teaching the concept of bending stress and beam failure. The traditional approach would be write the formula on the board, derive it, explain the terms, solve a numerical problem. Student copy everything and done. But imagine this alternative approach. Start your class by showing student a photograph of real crack beam, maybe from a breach, maybe from a building structure, and then ask them, look at this. Why did this beam crack? What do you think went wrong? Let them observe, let them speculate. Some might say the load was too high, some might say the material was weak, some might say the design was faulty. Now divide them into a small group of 4 to 5 students. Give them 5 minutes to discuss and come up with the possible reason. After the discussion, now introduce the bending stress formula. Suddenly, it's not just a formula, it's a tool to investigate a real failure. It has a meaning and it has a context. You can guide them to analyze, was it a material failure? Was it a design issue? What was the actual stress versus allowable stress? You see the difference. The formula is the same, but the learning experience is completely transformed. Another example is of thermodynamics subject. If you are teaching about the thermal efficiency, traditional ways to define the efficiency, write down the formula, explain how to calculate it, solve the various problems in active learning way, present a real industrial case. The efficiency of a thermal power plant has suddenly dropped from 38% to 32%. The management is concerned. As an engineer, what could be the possible reason? Now let the student think like engineer. Could it be a heat losses? Are there irreversibility in the cycle? Is the condenser not working properly? Is there a problem with the fuel quality? Give them time to brainstorm. Let them debate. Let them research. And then guide them to the theoretical concept that explain this real phenomena. This is not just teaching a thermodynamics. This is a training engineer to think. Another example is of fluid mechanics. Instead of just explaining a pump equation, give them this problem. In a residential building, water is not reaching to the top floor. Residents are complaining. You are an engineer called to investigate what could be the causes. Let student analyze. Is the pump capacity insufficient? Are there excessive friction losses in the pipe? Is there leakage somewhere? Is the pump operating point on the characteristic curve correct? Suddenly, heat loss, friction factor, pump characteristic, all the concept become tools for solving a real problem, not just exam topic. One more example from the manufacturing background. If you are teaching about the cutting tools and tool wear, show them actual photograph of one out cutting tool from a workshop or industry. Display different wear pattern, flank wear, crater wear, build up edge. Ask them, why is this tool wearing out so quickly? What could be going wrong? Let them think. Are the cutting parameters too aggressive? Is the tool material not suitable? Is the cooling method inadequate? Is there vibration in the machine? Then teach them the theory of tool wear, tool life equation, Taylor's equation, but now with the real context. These are not only a hypothetical example. If you follow this, the engagement level, interest level, and the depth of understanding, it will completely change and completely different. Now we cannot talk about active learning in 2025-26 without talking about the technology. Today we have the access of so many digital tools that we can transform our classroom. Likewise, Kahoot, Google Form for live polls and quizzes, instant feedback, instant engagement, virtual lab and simulation where student can experiment without physical equipment, MATLAB, AutoCAD, ANSYS for hands-on design and analysis, LMS platform for discussion, assignment, collaborative projects, even simple WhatsApp group can be used effectively for peer learning. These tools can convert a monotonous 1 hour lecture into an interactive, engaging learning session. But this is again important. Let me be very clear about one thing. Technology is not a replacement for the teacher. Technology is a support to pedagogy. The tool itself won't teach. You need to design the learning experience. You need to choose the right tool for the right purpose. You need to facilitate the learning. Now let's talk about the assessment because this is where a lot of us get stuck. In active learning, Assessment is also different. It cannot be a just mid semester and end semester examination. Active learning requires continuous assessment, formative assessment during the class activities, peer assessment where students evaluate each other's work, self reflection where students think about their own learning, rubrics that clearly define what competency looks like, portfolios where students showcase their learning journey. We are not just checking if students remember facts, we are assessing whether they are developing skills, whether they are able to apply the knowledge, whether they are thinking critically. And yes, I know this sounds like more work for us, but if we design it well, much of this assessment can be integrated into the learning activities themselves. It doesn't have to be separate burden. Now, I want to be completely honest with all of you about the challenges because if I don't address this, you will think easy for him to say, but in my situation. So, let's talk about the real challenges we face. The first challenge can be a large class size. Many of us are teaching 60, 80, even 100 students. How do we do active learning? There is a solution. You don't have to engage all 80 students simultaneously. Use small group discussion. Use think, pair, share activities. Even in large classes, you can create a small pocket of active learning. Second challenge can be a limited time. We have to complete the syllabus within limited time. How we can spend more time on the activities? The solution is we have to start small. You don't need to convert your entire course overnight. Even 10-minute micro activities in each lecture make a huge difference. One good activity per week is better than no activity at all. Third challenge can be student hesitation. Students are used to passive learning. Initially they resist participation. Basically solution is build it gradually. Start with the low stake activity where there is no penalty for the wrong answer. Appreciate participation. Create a safe environment for student. Over time, they will open up. Next challenge can be a lack of resources. Not all the colleges have the high-tech facilities. Actually, active learning doesn't always need technology. Simple case study discussion, a group problem solving session, a peer teaching activity, this need no equipment, just good design is required. The point is, don't wait for perfect condition. Start with what you have. Start small, but start. So, what does all this mean for us as an engineering educators? How does our role change? In a traditional classroom, we are the expert who knows everything and we transfer that knowledge to the student. In an active learning classroom, we become facilitator who create learning experiences, guides who help student navigate their learning journey, mentor who supports and challenge student, designers who plan activities and intervention. We don't need to know everything, but we need to know how to help student learn. We don't need to lecture for 1 hour, but we need to design experiences that make student think for 1 hour. This is real teaching, not just delivering a content but transforming student. And I believe this is also much more satisfying for us as a teacher because at the end of the day, when you see a student eyes light up with understanding, when you see them confidently solving a problem, when you see them becoming independent thinker, that's when you know you have truly taught. So, to wrap up everything we have discussed today, active learning is not just a trend or a buzzword. It's not some fancy educational fashion that will fade away. It is a necessary if we want to produce engineers who are truly ready for the challenges of the modern world. If we genuinely want our student to succeed, not just in examination, but in their career and life, then we must make this shift from teacher centered to student centered learning, from content based to competency based education, from passive listening to active engagement. Will it be easy? No. Will it take effort? Yes. Will it be worth it? Absolutely. Because at the end of the day, our goal is not just to complete the syllabus. Our goal is to build engineers who can think, who can solve, who can innovate, who can contribute meaningfully to the society. And active learning is the part to get there. Thank you so much for your patience, your attention, and for being here today. I hope this session has given you some practical ideas and inspiration to make your classroom more engaging, more effective, and more impactful. Special thanks once again to the FDP organizing team for this wonderful opportunity and to all of you for being such an attentive and enthusiastic audience. Thank you and all the best in your teaching journey. Thank you.